R5 Objective 1 and 4, we're going to be discussing factoring the greatest common factor for Objective 1. And then Objective 4 is factoring using a difference of squares. I'm going to go through this fairly quickly because you guys have all done factoring before. We'll talk through all these different parts. When you're factoring the greatest common factor, GCF, okay, what you're going to be doing, essentially what you have to understand about factoring greatest common factor is that you're undoing the distributive property, right? So what your polynomials that you start with usually are, if you can think of it as if you had a term out in front of a group of terms that you were multiplying out and you got a final sort of answer. What we're going to do is undo that. That's what factoring is. It's all undoing those different types of multiplications. So here's a type of problem you're going to see, all right, where it says you've got a polynomial and what we're going to do is undo any distribution that existed. Okay, and the way that we do that is, the thing that I will say about factoring using the greatest common factor is that is something you should always check for when you factor. Whenever you enter some kind of problem that requires factoring, you should always look for a greatest common factor first. It'll make your numbers more manageable. It'll be easier to see what numbers factors might have in common and breaking it down so that's a little more simplified for you. Okay. So now I'm going to give you the steps on what you would do in a problem like this. Okay. So your first move is to find the greatest common factor of all the terms. And keep in mind what greatest common factor is. It is the biggest number that goes into all of the numbers. And it will be equal to or less than all of the numbers. It can't be bigger than that. Those are multiples. We're talking about factors or numbers that make up that number. So I like to break this down with greatest common factors when we're dealing with variables into two parts. One with the coefficients, the numbers, and two with the variables. So the first thing is going to be find the greatest common factor of the coefficients. Now, in many cases, you'll be able just to look at it and think about it and go, what's the biggest number that goes into all of those numbers? And sometimes it's one of those numbers. Other times, you might want to break it down using a factor tree kind of system and then figuring out what's in common. What's important is that when you're using greatest common factor to factor, it needs to be in common in all of the terms. Okay. We'll get into partial factoring at some other point, but if it's not in common with all of the terms, then it's not in common. Okay. The other thing I want to point out is if you're ever in a situation where your polynomial is already in descending order and the leading term is negative, that's when you're going to want to factor out a negative. Okay? That's really the only time you ever factor out a negative greatest common factor is if this leading term is negative. So let's just assume you can't figure out what the greatest common factor between 4, 8, and 12 is. What you would do is essentially create a factor tree of those things. Okay, and I've gone ahead and done that for you already. And notice I dropped the negative 8 out of there because, like I said, if the front term isn't negative, then we're going to be factoring out a positive anyway. So, of course, we can break all of our coefficients down into their prime factorization, their prime factors. And then we see what's in common in all of them, right? They each have what?
2.
How many 2's do they have each?
2.
They're 2 2's in common, right? They each have 2 2's. Okay, that's what they all share. So, of course, that is what? What is 2 times 2?
4.
So, our greatest common factor for the coefficient part is just 4. Okay? And I know you probably all knew that without having to make the factor trees. As the numbers get bigger, this may be something you want to do. Okay? There's my 4 is my greatest common factor of the coefficients. Now, with the variables, there has to be that variable has to be common in all of the terms, first of all. And then second of all, it's just whatever the lowest power is. Okay? So when I'm finding the greatest common factor of the variables, I'm just looking for the variable with the lowest power, assuming that they're all in common. Right? Like they all have an x. If they all didn't have an x and two of them had an x, it's sort of like the numbers. It's not in common in all of them. Right? So in this case, I've got an x to the third, an x squared, and an x. This is in descending order. So my x is going to be my lowest power, raised to the first power, which means that's the variable part. Okay? So all of this combined together, what this tells me is that the greatest common factor is just 4x. Okay? That's the biggest number that goes into all of the terms. Right? And if you wanted to, you could break the variables down with a factor tree like I did before and have x times x times x, x times x, and then an x, and you'd see, oh, they only have one x in common. It's always the lowest power on the variable. Okay? So then here's the next part. Once you find the greatest common factor, you're just going to, again, remember that we're undoing distributive property. So this is the number that would go out in front of the parentheses to make it look like a distributive property problem again. All right? So that's what this last step says. Put the greatest common factor in front of the parentheses, and then to come up with whatever's on the inside is take the original problem and divide all of those things by the greatest common factor. Right? Again, we're undoing that whole process of distribution. So here's what that would look like. 4 times the parentheses, and inside here, what I'm going to do is take my original problem and divide each term by 4x. And that's how we get a simplified form, so it looks like this. And I highlighted the 4x because that is the greatest common factor. So this is my original problem, 4x cubed minus 8x squared plus 12x, and then I divided by that greatest common factor, which will reduce this original polynomial down to something that existed before it all got multiplied by 4x. So go ahead and finish that. I wrote this out this way for your benefit. I don't necessarily expect that you write this out. I believe you can do this division in your head here. But if you get lost, you get confused, or you feel like you're still shaky on factoring, I recommend writing this out until you feel like you got your feet under you again. Okay? So, of course, 4x to the third divided by 4x is just x squared. And then 8x squared divided by 4x is 2x. And then 12x divided by 4x is 3. So this all equals 4x times x squared minus 2x plus 3. And again, if you wanted to see if this was correct, what you should do before you move on is first check to see if these three terms have a greatest common factor anymore. Because if they still have a greatest common factor, they have a factor in common between these terms inside, that means the number that you pulled out wasn't big enough. You pulled out a common factor, not a greatest common factor. So check that. And then if you just did this distribution in your head, does it equal my original problem? And if it does, then you did it right. Okay? Hopefully that's just a quick little review, greatest common factor, and that wasn't too bad. Then, are there questions before we move on to difference of squares? Okay. So let's look at, oh yeah, and there's my final answer. Actually, yeah, let's do one first before we do difference of squares. Here's one on your own. Do that one, let's see what you get. Common factor here.
2x to the third, y to the fourth.
2x to the third, y to the fourth, is that right?
Yep.
So 2, yep, x to the third, lowest one, y to the fourth, good. Then you do your division, you get 11x squared, y to the third minus 7, y to the fourth, plus 9x to the third, yeah? How's that look? How many of you got that? Questions? All right, here's the nice looking answer. All right, let's talk about difference of squares then, okay? And then we'll be done. So that's objective 4, factoring a difference of squares. We're gonna do 2 tomorrow, Friday, 3 on Tuesday. Okay. So what's important with factoring a difference of squares is making sure it meets all the criteria first. Okay, if it doesn't meet the criteria of what the name is, difference of squares, then we can't use difference of squares. Alright, and so in reality, here's the criteria. The first criteria is this: there must be exactly 2 terms. Cannot have more than 2 terms. And then the word difference tells us that it's going to be what type of problem?
Subtraction.
Subtraction, correct. Okay, so it's got to be subtraction. There's no such thing as a sum of squares in terms of factoring. It's only a difference of squares. Alright, and then what do we know about those 2 terms? What do you think? So we got difference taken care of. We know that there's 2 of them. What about this squares thing? What do you think that means?
The powers.
Yeah? Kind of. It means it's a perfect square. Now these perfect squares can be variables, they can be numbers. They can sometimes be both. So long as the term is a perfect square, meaning it has a square root that comes out evenly, then it's a perfect square. Okay? And here's the general form that we're talking about here. What it will look like is if you have some number that's a perfect square minus some number that's a perfect square, the way that we factor it is we take the square root of this one and it goes in the fronts, the square root of this one and it goes in the backs, and one of them's plus and one of them's minus, and the order doesn't matter. You could have had plus then minus, minus then plus, it doesn't matter. That's the general kind of idea, general form of factoring a difference of squares. Okay? So long as this is a perfect square, you can take the square root of it. So long as this is a perfect square, you can take the square root of it. It's got to be subtraction. Okay? So there are 4 examples. All right. Let's work through the first one together, and I'll let you work on the next 3. Okay. Before you try to factor using difference of squares, you should always check for greatest common factor. If there isn't one other than 1, then we can look at some of the other methods. On this first one, x squared minus 25, is there a greatest common factor besides 1? No. Is x squared a perfect square? Is 25 a perfect square? Is it subtraction? Okay, so it meets all the criteria. So what is the square root of x squared? X, square root of 25? Okay, so go ahead, what would that look like as factored? What goes in the fronts?
X minus 5, and then x minus 5.
Nope. Yep, one minus. X minus 5, x plus 5, or x plus 5, x minus 5, okay? How many remember doing that before?
Yes.
Good, alright. Does this meet all the criteria? Are there 2 terms at subtraction, they're both perfect squares?
Yep.
Okay, so how would it factor?
P minus 8, P plus 8.
Yep. Say P plus 8 or P plus 8, P minus 8. Alright, how about C? Are we good? Does that meet all the criteria?
No. Must be subtraction.
Must be subtraction. This is addition. Okay, this does not have a greatest common factor. We can't do anything with it. So we say either, you can say it's prime or you can say it's not factorable. Okay? So even though this is a perfect square and this is a perfect square, because it's addition, you can't factor it. And those of you who think, well, why can't I? Why can't I do that? Just multiply back out what you came up with to see if you get that, and you'll find out that you don't. You can't, I should say you can't factor this using just the real number system. You can factor it using complex numbers, which we're not doing in this course.
If it's plus, does that mean you can never do it?
If they're both perfect squares and they don't have a greatest common factor, correct. Alright, how about this last one? Is this one good? Are these both perfect squares, subtraction? 8's a perfect square?
No.
No? So what should I do?
Leave it,
Greatest
or you
common
can try.
Greatest common factor, what is that?
two.
2. So if I pull a 2 out, now I look at what's inside the parentheses. Do I have a difference of squares now? Okay, so now just keep going, and the 2 just kind of hangs along for the ride. Okay, so you can factor this like it's its own problem, because what's the square root of 4x squared? Square root of 4x squared is 2x, square root of 49y squared is
7y.
7y, okay? So that goes along for the ride, and I've got the 2x minus 7y, 2x plus 7y. Okay, so here's a type of problem where we can combine more than one method together and still break it down a little bit further.